Good morning, 8th and 9th grade. I'd like to talk about just the periodic table just a moment. Yesterday I ran out of time and didn't get that far. So this morning I'm actually going to put a second video on later. But this is the first video that will finish up yesterday's lesson and also get you started for this lesson. So the periodic table looks like this. You can also find it right inside the first cover of your book. If you look there, you will find the chart, is the way he refers to it, the periodic chart of elements. Now, it's pretty important that you understand how this works because you're going to be using it the next couple days to do your work. You're going to be looking at it. And matter of fact is, even on your test, your study guide and your test, you will refer to this. So you'll be able to open up your book to do your test and look on the first page and get the information you need off of there for your elements. Again, let me refresh with you. The big number is your protons, like the first number in the letter is your protons, and then you have a letter of the alphabet. And if you look, the first letter is always capitalized every time. Now sometimes some of the elements have two letters to be able to tell the difference between them. And if they have two letters, the second letter is never capitalized. So it's not proper to capitalize both of them. And then if you look exactly down here, especially down here in the bottom over here toward the right hand side, you will find that there's some elements that have three letters, and that's not a proper way to write an element. But the reason that they have three elements or three letters in the element, and I put it here on the board, the first letter is capitalized, and they're either English or Latin words. There we go. I should make that clear that the elements, they are going to be the word of either English or Latin, so it's not going to be easy to always figure out what the element is by the letter. And then the ones with three letters are ones that are new, or they are relatively been discovered or made, would be probably a better way to say it, by scientists. And we haven't given them an official name yet, or scientists haven't given them an official name. They're still trying to figure out what name to give them. So for right now, they just give them three letters, and with time, they will name them properly and give them a two-letter name. And then, of course, the atomic number is your bottom number. And so if I can, in the box, if you look in the box, and if you notice that a lot of times the atomic number, especially on some of them, is a tenth of a decimal. And this is the estimated number because the number of neutrons keeps changing in an atom depending on the chemical or the element. And so it's not a stable number, so they give the average of the element. So that means that's the reason they come up with a tenth. If you're looking, it'd be the average number in the element, the average number of neutrons. So let me just refresh with you again. If you look on page 322, it will go over what I just mentioned. It will tell you about the elements. You read that and then turn back to your page. As you read it, you turn back. He uses the illustrations. On 322, he talks about how that we use a Boyer model, and that's on 323, is a model of the atom. Now, there are rules. We talked about the protons and the neutrons are in the center. They make up the nucleus. And then you have these electrons going around the outside. In the Boyer model, he has a chart. And so turn over to, because of the Boyer orbits. For the electrons to orbit the nucleus, you have to look at the chart on the table 3.1, which is on page 324. So if you have your protons and your nucleus here in the middle, Then out here, going around, maybe I should draw that line solid, your electrons. And on your chart on top of 324, the first orbit can have 2. So we'll make these guys big. He can have 2 electrons. The next orbit can have 8. Now, if you want this explained in depth, you will have to do research outside of the book. Why some have 2, why some have 8. But if you look there, the orbit number 1, which is the closest to the nucleus, to the center, he has 2. The next one has 8 around there. And I'm not going to put it down here. I'm just going to put an 8 on there. The third circle, okay, and then if you've got all of them used up, then you're done. Okay, if you're doing one that has 10 protons and have 10 electrons, then you're done. You just have 2 orbits. But say for instance it has, like the example, let's say it has more. The third one, the third circle around can have 18. I'll put him. He can have 18 of these guys flying around in the third circle. Now it's getting bigger. And when I'm saying bigger, you understand what I mean here. Bigger is still tiny. And then if you look, the fourth circle can have 32, and the fifth circle can have 50. So here, if you add those all up, you can see you can get almost all the elements that are on the chart, the periodical chart. You can get all the elements in those circles. And so you just keep adding. If you can get them all in 2 circles, 8 and 2, so that'd be 10. If you can get them all in that, then that's all you make. If you need 18 more, you can add the third circle. You start in with as into the center with 2, and then you keep increasing till you run out of electrons. If you're drawing a model, using the Boyer model, if you're drawing an atom, I should say, and you want to put the electrons, there'll be 2 in the first one, there will be 8 in the second one, and if you run out before you get to all of the 8 on, then you just put the remainder in the second row, or in the second orbit, if I say it correctly. Go ahead and read your next part about the strong force. I will talk about that here in a little bit, but I'll put the second video on, so this will be part 1, and then I'll put part 2 on later today. Thank you.